Hello everyone, I'm Hideki Tsuiki, presenting from Kyoto. It is a pity that I cannot attend physically, but I'm very pleased that I can join virtually after teaching class this morning. This is a puzzle that I designed and presented here at G4G14 10 years ago. It consists of 3 red polyhedrons called H and 6 yellow polyhedrons called T. The objective of this puzzle is to put all of them into this box. Last year, this puzzle was commercially produced by Image Mission Inc., and it is available at Rover's Father's shop in the sales room. So please have a look at it at his shop. H and T has these shapes, and they fit into this small box. And when they are in this box, they look square from all the 3 directions of the cube. This property is called an imaginary cube, and H and T are imaginary cubes. Now, this box is double-sized, and therefore it is easy to put 8 of them, but there are 9. So it is a puzzle. This puzzle contains so much fun and mathematics, so in these 10 years, I have used it in math classes from elementary school to universities. This is a picture at a junior high school, and this is a picture of my university class this morning. Through these activities, I'm convinced that it is a good material to teach the essence of mathematics, which I want to share you today. In classes, I give hints gradually. I suggest to make an exercise to put 8 pieces as if they are in small boxes, and ask where the last one go. Yes, one can gather the truncated vertex as the center to make a space for one. Then, which one comes as the center? H or T? People usually try to put H, maybe because 3 is an odd number. I also give the hint that it has a solution without gaps between pieces. Let's try it. We try to start with H. In order to make an open space at the center, it is natural to put it in this way. Then, in order not to leave a gap, we have to put one with the same face in the next box, which determines the pieces almost uniquely. When we have 4 pieces, we have a hollow which exactly has the shape of T, and we can proceed. And done. You can see that it has so beautiful 3-fold symmetry, and it is a part of 3-dimensional tiling with many characterizations, and it is related to many branches of mathematics which I'm teaching at my university. In junior high school and high schools, I use 2 successive classes. In the first class, students enjoy the puzzle and everybody comes to the solution. Then I ask the question, have you really solved the puzzle? Yes, it looks like that 9 pieces are in the box with a gap. But can you guarantee that? There may be a small gap that our eyes cannot perceive, in particular at this stage. And I may be cheating and you may be persuaded to believe in a fake fact. How can you make it sure with 100% confidence? It is possible only through mathematics. The space left at the center by the other 8 pieces has this shape. Therefore, we need to prove that they are congruent. If they are congruent, then the 3 diagonals of T are orthogonal to each other, and T is obtained by taking 6 vertices on the axis of coordinates. If the distance from the origin are the same, then it is a regular octahedron. Here, the length is 1 and 2, and the longer length is equal to the side length of the small box. How can we prove that they are congruent? I have 3 proofs. One uses Cauchy's theorem, which is immediate, but Cauchy's theorem itself is difficult to prove. Another one is to use inner product to prove that these diagonals are orthogonal. It is very nice for classes in high school, but it is impossible for junior high school. We show the third proof which is an elementary geometrical proof. We show that these two diagonals are orthogonal. We put another box over this box and consider this isosceles triangle. Then one can see that this trapezoid is the lower half of this triangle. By the way, we draw 4 of these squares and look at this triangle. Then the 3 edges of these two triangles are the same and they are congruent. And in this trapezoid, it is obvious that the diagonals are orthogonal, and this length is the side length of the small box. This is what I'm doing when I visit junior high schools. In this way, we give strong motivation through a puzzle and then show an elegant and easy proof understandable with the knowledge given at elementary school, and the students are excited at understanding it. My goal of the class is to offer an experience to understand something, not through experiments, but through logical thinking. This mathematical attitude is the most important thing to teach, I believe. So, the imaginary cube puzzle is a good teaching material. This puzzle is an enjoyable hands-on activity which requires deep thinking. It is based on beautiful geometry and it is related to many branches of mathematics. In addition, we can teach the importance of proofs and mathematical understanding, which I suppose that most STEM activities do not emphasize. Finally, my exchange gift is a Sierpinski Tetrahedron with 1024 pieces. It is also an imaginary cube as this picture shows, and please enjoy the attractive figures it makes under sunshine. You can see the details here. Thank you very much.